When I was a teenager, my parents arranged for me to work on farms and to gain experience of that way of life, and that's attracted me a lot. So I thought of going and studying agriculture and carrying out advisory work overseas in developing countries, and went to the University of Nottingham's School of Agriculture. I wrote to laboratories at progressively greater distances from there until one of them would accept me as an intern. And the first person to accept me was Chris Polge, working in the University of Cambridge. And that led naturally to a great opportunity to stay with him to work on embryo freezing. And a few years later, we produced Frosty, the first calf to survive being frozen and thawed.
But this is not strictly related to cloning. How was the preparatory work towards Dolly?
Well, after I'd completed that work, I moved to the institute, which is now known as Roslin Institute, and was involved in a project in which additional genes were added into farm animals. And this taught me a lot about molecular biology, the fact that you can change animals, but that method was too primitive. It could only add genes, it was very inefficient, and so we began to think of other ways of being able to change genes in the animal. And we realized that if you could have embryo stem cells, then you might be able to use standard molecular biology to change genes and then clone from those.
So at the end, Dolly was intended to produce stem cells, not for reproductive purposes?
That's correct. Our objective was to be able to change genes in farm animals, to make them healthier, perhaps to produce organs which could be transplanted into human patients.
At the time of the birth of Dolly, the sheep, were you aware of the impact he was going to have?
I think we understood that there would be some, but we didn't understand the huge impact. I mean, immediately the Institute was swamped with television crews, newspaper people from all around the world, and it lasted for weeks and for years. Even now, 15 years later, you know, we're talking about this subject, so we didn't expect it to have quite such a big or long-lasting effect.
Why do you think that cloning has not worked so far in the human being?
That's a really interesting question, which is still not really understood. People have made some progress in the last year or so, that there's clearly something different about the egg. So when the chromosomes are removed from the recipient egg, something else is taken out at the same time, which is essential for normal development. It's still not known what it is, and until that's known, it's not possible to think, is it possible to reintroduce it into the egg in some other way and give it the competence to develop normally?
We are in an impressive biomedical research center here. What kind of, or what areas of research are you covering here?
The Dolly experiment made me realize that we can change cells far more than we'd believed possible in the past. And so our research is in developing methods that make it possible to change skin cells into nerves. So that if the skin cell came from somebody who has an inherited neurodegenerative disease, then we can hope that there will be differences between the nerves taken from that person and a nerve from a healthy person.
Reprogramming has been achieved with induced pluripotent stem cells. What is the comparison between these cells and somatic cell nuclear transfer? And how far do you think we are from cell therapy with pluripotent stem cells?
I think that the IPS technology still needs some refinement, but it's already useful. We've made some interesting observations using IPS cells, studying motor neuron disease, for example. So despite their limitations, they are still useful. I think as far as cell therapy is concerned, we definitely need to improve the technique, but it will certainly happen one day, and it will provide new opportunities to treat large numbers of patients at some time in the future.
Gametes have been obtained also from pluripotent stem cells. Do you think we will be able to use these gametes for clinical therapy?
I think it's very likely that that will happen for sperm, because they're relatively simple period of development. But the oocytes are a much bigger challenge. I mean, literally it is much bigger, it's a very big cell, but it goes through complex changes, so it's a real challenge to think of producing oocytes.
I wanted to ask you, what has been the impact that has been produced by your biomedical research in your vision of life?
A very interesting question. As you go through life, you see inevitably that human life is really quite frail. You have friends and colleagues who have diabetes and cancer and MS and motor neuron disease. But the thing which is exciting from our research is that there really are opportunities to develop treatments for at least some of these diseases. And so I find that a very exciting and encouraging opportunity.
What would be your recommendation to young scientists that want to start their career in biomedical research?
Be ambitious. There's no point in doing experiments which have essentially been done before. So think of experiments and think, you know, is this really the most ambitious experiment that you can do? If it is, well, you know, do it. But be ambitious would be my advice.
Professor WILMUT, I wanted to thank you for answering our questions. I wanted to thank you also for your work. And as you will not be able to be with us in Istanbul next July, I wanted to take the opportunity to give you this award. This represents the honorary membership of our society, and we are really honored that you accept this award from the ESHRE. Thanks a lot.
Thank you very much indeed. I'm really sorry that I can't be at the meeting, but I have a prior commitment. Of course, I am absolutely delighted and excited and flattered to accept this award. It's a great honour. But I would like to emphasise one point. Research these days involves a whole team of people, and so I accept this on behalf of the whole team and say thank you very much indeed.
Thank you.